Welcome. In this video, we're going to give conclusion to the methods of integration. We have seen various methods of integration. We have seen that we can just find integration by directly applying the formulas. We have seen also how to find integration using substitution UDU, integration by parts, integration by trigonometric identities. So in this video, we're going to solve various examples and we're going to know when to apply all of these formulas. So let's say, for example, we're given something like this. You have e raised to 3x dx. This is simple application of formula. So what you're going to do, this is equal to, you keep whatever this expression is, 3x, and then you divide by this value here that is multiplied this x. So it's going to be divided by 3, and then because this is an indefinite integral, it's going to become plus c. So this is our case number 1. Now our case number 2, let us make a small modification to this. Say for example you have e raised to 3x plus 2 dx. Okay, this is different now because we have now this part and also have this part here. How should we solve this kind of expression here? Now, one thing we may try to do over here is that we know that whenever we have an expression like this, we can simply have this number here and then we put it down and then we keep whatever the thing is. So one of the ways that we have to do this thing is if you make whatever is here on top to become one single variable, like here, one single expression. And one of the ways to do that is to make it substitution UDU. So we have 3x is going to be, if you make a derivative of this, it's going to give you what? It's going to give you 3 dx is equal to du. So our dx is equal to du divided by 3. Okay, so in this case what you're going to do is you're going to have here integral of e raised to, instead of all of this you're going to put only u. Instead of dx you're going to have here du. So we have here 1 divided by 3 integral of e raised to u du. Now we can just do this. So we're going to have here 1 divided by 3 and this is going to be e raised to u. This is a 1 multiplying this u. In this case it was 3, but in this case now it's 1 divided by multiplying u. This is going to give us 1 divided by 3 into e raised to 3x plus 2, which is equal to e raised to 3x plus 2 divided by 3. This case here is complete. Let's take another example. Let's say for example you are given something like this. Let us say you have integration of 2x cubed dx. Fine. One of the ways to solve this thing is simple. This is a constant, so you take the constant, you put it outside. You're going to have 2 and then you're going to have here x cubed dx. Right? I know that this thing to solve it's very simple. You just have to apply our formula. 4 and then I'm going to divide by the same power 4 and then you're going to put plus c. So this is going to be equal to what? It's going to be equal to x raised to 4 divided by 2 plus c. Now let us say that we have another example here. So we're given something like this. Now we have integral. This is the fifth root of x. All of this thing here, the x. Now, how do we solve this thing? We may feel threatened because we see here the square root and none of our formulas actually shows us when we have a square root, but we know one of the properties of the roots. So this is the same thing as if you say x raised to 1 divided by 5. So this 1 here is the power of this x here and this 5 is this index here of this root here into dx. So from this point I think you already know how we should do this. So we're going to have here x raised to 1 divided by 5 plus 1 divided by 1 divided by 5 plus 1. So that's what you're going to do here. So then I'm going to do LCM. This is going to be our 5 here. This is also going to be our 5 here. So as a result, this is going to give us what? This is going to give us, if you're going to see, this is going to be x here and then here 5 multiplying, then it's going to become 6 divided by 5 and this is also going to be divided by 6 divided by 5. So this is dividing here when the number that is dividing. So this is going to be, you take this thing, put it up, you're going to have here 5x 6 divided by 5 divided by 6. Done. Simple example. Now let us say we have another example here. We're taking now let's say the integral of 10x cubed minus 2 sec square x. All of this thing here is dx. Now we have seen that whenever I have a situation like this, remember that here the operation is subtraction. Whenever I have subtraction and addition, you can just separate it. So I can separate this into two parts. We're going to have the first part 10x cubed dx minus the second part, which is integral of 6 square x dx. Now if you try to solve this thing from here, what you're going to see, this 10 is a constant, so you take this 10, put outside, and then you're going to have your x cubed dx. And then here this 2 is constant, so it comes outside. You're going to have here 6 square of x dx. This is going to be equal to what? It's going to be equal to 10. This region is going to increase the power, so we're going to have here x raised to 4 divided by the same power, minus, we're going to have here 2. When we have 6 square of x, this basically we have a standard formula for this situation, so this comes as 10 of x. Because we're dealing with indefinite integral, this is going to become plus c. So in this case also could take it plus c. Fine, simple. So we just applied here linearity. We just separated, then we found it. What were the results of each of them, and combined they give us the integral that we are finding. Now let's take another case here. Let's say, for example, we have something a little bit more different. We have here x into square root of x plus 1 dx. So how do we solve this thing here? Well, one of the ways we can solve this thing here, if you try to make substitution u du, because we have an x here, you know that this can be easily simplified into an u, and then if we do so, we're having a chance of combining these two things here. So let us try to see what we're talking about. So let us try to see, whenever we take always the most complicated thing or the longest thing here. So u is equal to x plus 1. So it means that our du is equal to dx. Great. So we can take this thing and say this thing is. Now this is x, but we don't have relationship of x here. So this means what? This means that x, if you take from this thing, you make some alterations, is equal to u minus 1. Fine. So instead of that, we're going to write here u minus 1, and then here we're going to have square root of u, because the value of u is x plus 1, and then all of this is dx, right? Oh, this is du, sorry. Now we're using another variable, du, relationship with dx. Fine, this is what we get here. Now, one thing we have, or we know, is that whenever we have square root of u or something, it's always 1 divided by 2. So this we can also represent as, if you are having u minus 1, and this is going to be u raised to 1 divided by 2 du, which is equal to, now we can take this and multiply here inside. You're going to have integral of, you're going to have here u, we're just going to add the exponents, so the power, this is 1/2 plus 1, so this is 3 by 2, so it's going to be 1/2, 3 by 2, minus, you take this and you apply here and minus 1, it's going to be 1 raised to 1 by 2, and then all of this thing is du. Now that we have this, what you can do is you can just apply linearity here as well. So this is going to give us integral of u raised to 3 by 2 du minus, you're going to have u 1 by 2 du. Now how do we solve this thing here? As you can see, this is just situation of the power rule. So what you're going to do, just add 1, and then you also add whatever this power is going to be in the end on the bottom as well, and then you can be happy. So this is going to be what? This is going to be u into 3 divided by 2 plus 1 divided by 3 divided by 2 plus 1 minus u 1/2 plus 1 divided by 1/2 plus 1. Fine. This is going to give us this expression in terms of u. Now this is equal to, here you just have to put 2 and then you know that this is going to be 5 by 2. So we're going to have here u divided by 5 by 2 divided by 5 by 2 minus, in this case we're going to have what? Going to be here we're having 2, and then this is going to be 3 by 2. So this is going to be 3 by 2, right? The denominator here is going to be 2. So because it's dividing a division, it becomes multiplication. So we're going to have here minus 2, and then we're going to have here 1. This is going to be 3 divided by 2, and this is going to become 3. This 2 was just being divided, this 2 was here dividing this 3, so it came here, became plus. Now we can just put here plus c, but since we are dealing originally with x, we're not going to put c now. So this is going to become is equal to, what is our u? As you have seen here, our u was x plus 1. So this is going to be what? X plus 1 5 divided by 2 divided by 5 divided by 2 minus 2 into x plus 1, 3 divided by 2 divided by 3, and this is done. Now in our last example, we saw a situation in which we are having, and last video saw a situation in which we are having integration by parts. So let us see something else here. Let us say we give an expression like this. You have here x minus 1 square into x plus 1. So all this thing is dividing 1, and then you are going to have dx. So the first thing we have to do here is to try to represent this expression here in terms of those unknowns, a, b, c, or whatever we're going to have. As you can see here, the degree of this here is 3. Okay, you're going to have here, we have 3 expressions. This is a square, it means we have 1, and then we're going to have the second one, and then the third one is different. So this is 2 times this expression here, x minus 1, and then plus this expression, so 3 times. So we can conclude from this that if you have 1 divided by x minus 1 square into x plus 1, this can be equal to a, this is a constant, this a is going to take the first part of this, so it will be ax minus 1 plus, going to have next b takes this whole expression with its power, this is going to be x minus 1 square, and c is going to take this less expression, so it's going to be c going to be divided by x plus 1. Fine, now you're trying to equate this thing. Okay, so in order for us to have this same power on all of these things here, what you need to do in this case here, we have to add 1 more x minus 1, and we add x plus 1. So this and this are going to become square, and then this here is going to complement, and we're going to get this. So this means that it becomes a into x minus 1 into x plus 1, this expression here, and then we're going to have plus b. We already have this x minus 1 square, so the thing that we're remaining with is x plus 1, so we're going to be x plus 1. And then finally we have c. In c we already have x plus 1, so what we don't have is x minus 1 square. Okay, now this expression here and this expression here, because here we're now finding LCM, it means that the denominator of this and this now is equated, so we're going to just write here 1. This is cancelling each other. If we got this expression here, it means that this is the same on the bottom, so then it comes here, it multiplies, and then you're going to simplify, you're going to only have 1. Fine. So the next step when you have this situation like this is that you're going to find ways of simplifying this, so that you're going to eliminate few of the constants and then try to get one constant at a time. So one of the ways that we will try to find a, b, or c is by replacing the value of x by some convenient number. So let us say, for example, x is equal to 1. Now when x is equal to 1, this becomes 1 is equal to, this is going to be 1 minus 1 0, so this whole disappears, becomes 0, and then you come to this one, 1 minus 1 also becomes 0, so you're going to have here is equal to b into 1 plus 1. 1 plus 1 is 2, so it means that 1 divided by 2 is equal to b. We already found the value of b. Now we have to find another variable. We have 3 variables here, so we need 3 values to replace in x. So let's say here x is equal to minus 1. I'm not choosing randomly, actually I'm trying to simplify this thing. So if I take x is equal to minus 1, this is going to become 0, because we're going to have minus 1 plus 1, and then it's going to become 0, so our a disappears. Again here we're going to have minus 1 plus 1 is 0, this b disappears, but these will remain here. So we're going to have here 1 is equal, this is this one, is equal to c into minus 2 minus 1 square. Okay, minus 2 square, this is equal to 4, so this is going to become 1 divided by 4 is equal to c. We already found what is the value of c. Now we have to find the value of b, of a. We have b and c. Now I found the value of a. Now I'm going to choose another number. I'm choosing 0 because 0 is a very small number, so it's easy to make to calculate using 0. If you can choose even 100, 1000, or whatever number you're going to choose, it's going to give you the same result. So let us say just here x is equal to 0. So we're going to have here 1 is equal to, now we're going to have here a, see, x is 0, so it means that a is equal to minus 1 into 1, so this is going to become what? Minus a. Fine, and then you're going to have plus b, because this x here is 0, so it becomes b into 1, and then you're going to have here plus c, so this is going to be c. You're going to have here minus 1 square, which is 1, so this is going to become plus c here. But we already know that our b is 1/2 and that our c is 1 divided by 4. Okay, so now what you can do from this thing here, you can just here make the LCM, so this is going to multiply here by 2, so we're going to have here 1 is equal to minus a plus, so this is going to become 2, so when 2 plus 1 becomes 3 divided by 4, and then take this 3 by 4, you bring it to the other side, so this becomes 1 minus 3 divided by 4 is equal to minus a. Fine, so this is going to become, what you need to do this for LCM is to put here 4. Okay, so this is going to become 4 minus 3 is going to become 1 divided by 4 is equal to minus a. So this tells us that a is equal to minus 1 divided by 4. Fine, so our expression now becomes this. So it was 1 divided by x minus 1 square into x plus 1. So this now will become, we're now replacing the value of a, for example, it's going to become minus 1, we're going to put here divided by 4. The value that we're having there was x minus 1, so this becomes ax minus 1. For the b, we're going to have 2x minus 1 square. This 1 by 2 is the value of b. And for c, we're going to have divided by 4 x plus 1. This is the value of this expression. So if you want to find the derivative of this, this is going to be equal to the, you can just take these constants outside. So we're going to have here 1 divided by 4. This is going to be 1 divided by x minus 1 dx, and then this is going to become here plus 1 divided by 2. We're going to have here 1 divided by x minus 1 square dx plus 1 divided by 4 integration of 1 divided by x plus 1 dx. So how do we do it? How do we deal with this? This is going to be equal to. Now, one thing we know is that if we have 1 divided by x, for example, the x, you want to find the integral of this, it gives you natural log of whatever that value is, natural log of x, okay, whatever is in the denominator. Okay, so these, because we don't have any power here and here, we can just try to assimilate this to this situation here. So what you're going to get is, we have minus 1 divided by 4 into, now instead of taking x minus 1, let us see u is equal to x minus 1, so du is equal to dx. Okay, so this is going to become integral of 1 divided by, this is going to become u now, u, and this is going to become du, so we're applying substitution u du here. Now another place, we're going to have here 1 divided by 2. Now if you make this thing also as substitution u du, this becomes a variable, and then if you pass it upwards, it's just going to use the power rule. So what you're going to do is, let us consider L is equal to x minus 1. Okay, so it means that dl is equal to dx. So this is going to become 1 divided by L square dl plus here 1 divided by 4, and then this one again is like this one, but we cannot use u because we already used u here, so we're going to call it w. W is x minus 1, so it means that dw is equal to dx. So this is going to become 1 divided by w dw. Okay, now we're going to have here minus 1 divided by 4. This is simple logarithm, natural log of u, plus 1 divided by 2. Now we have this. We cannot apply log for this thing, so but what we can do is take it up and see this is equal to L raised to minus 2 dl. So this can be applied, it can be solved using the power rule. Plus 1 divided by 4 natural log of w. So this is going to give us minus 1 divided by 4 natural log of u plus 1 half. This thing you're going to do at add 1 of power is going to become minus 1. So then you're going to also divide by minus 1. So at the end of this, what you're going to have here is L raised to minus 1 divided by minus 1. So this can be also equal to minus 1 divided by L. Okay, minus 1 comes down, becomes just positive. So that's what you're going to get from this point here. Fine. And then yes, we then close this thing here, and then you're going to have here plus 1 by 4 natural log of w. We know that our u is 1 minus x minus 1, so this is going to become natural log of x minus 1 plus 1 by 2 into minus 1 divided by L. L is x minus 1. I'm going to have here 1 divided by 4 natural log of w is x plus 1, not minus. W is x plus 1. W is x plus 1. And then you're going to just put plus c because this is an indeterminate integral. So this would be as an exercise that we apply in the substitution by parts. Finally, we also saw situations in which we have to use integration by UDV or integration by parts. Say for example you're given something like this. Let us take x raised to e raised to minus 2x dx. Now in order for us to solve this thing, we always have to remember that we have priorities here. You can use this called lit, sometimes they call it isolate, and various denominations for that. Logarithm, inverse trigonometric, power of x, trigonometric exponential. Okay, so we are going to follow this rule here to find what is going to be our u. Okay, so logarithm we don't have, inverse trigonometric we don't have, power of x we have this power of x. So this means that this is going to be our u. If this is our u, it means that this one is already our dv. Okay, so with that what we can say is u is equal to x, and then dv is equal to e raised to minus 2x dx. So this du is equal to dx. We found it. Now we have to find v from this point here. Now v is what? V is the integration of all of this. Now let us find the integral of this. So v is equal to integration of e raised to minus 2x dx. Now to solve this, because of how this thing is here, let us apply substitution, integration by substitution. So to apply integration by substitution, how are we going to do this? We're going to say, since we already used the u here, let's use another variable. Let's call it t. T is equal to minus 2x. Okay, so this means that dt is equal to minus 2 dx. So we know that dt divided by minus 2 is equal to dx. Great. So with that said, what we're going to do, we're now going to replace on this value in this integral here. So we're going to have v is equal to integration of e raised to minus 2x is t, e raised to t, dx is dt divided by minus 2. Okay, so this is equal to 1 minus 1 divided by 2, because this comes outside, and then you're going to have e raised to t dt. Now this is it. We have 1 multiplying to this t here, so we're applying the same rule we use for the exponential function. So this is going to become minus 1 divided by 2 into e raised to t. Okay, and then we would use here plus c, but since this is just an integral which is being solved within another integral, so there's no need of putting constant c now. We're just going to put c at the end of it. So this is 1 here, so it's going to be dividing this one, going to become also 1, but you don't have to write it. Okay, so we already found the value of v. So v is equal to minus 1 by 2 e raised to t, but it should be in terms of x. We know that t is minus 2x, so this is going to become here minus 2x. Done. So this is the integral of this function here, dv. Fine. Now we have to apply the formula we use when we're dealing with substitution u dv. Now the formula we apply is, we know that integration of u dv is equal to u v minus integration of v du. Now the next thing to do is very simple. This is going to be what? We're just starting from this onward, okay? This expression you already have that it was at x raised to, let's write it, okay? So this is going to be what? X, and then here we're going to have e raised to minus 2x. This is the integral they asked us to find. Is equal to u. What is our u? Our u is x. And then we have here v. V, we already found what was value of v. It was this one here. So this is going to become minus 1 divided by 2 e raised to minus 2x, which was our v. And then we're going to put here minus integration of v. Now integration of v, we know that v is this expression here. We already found it v, okay? This one. So we're going to become minus integration of minus 1 divided by 2 e raised to minus 2x, and then we're going to have here du, and du is the same thing as saying dx. Now this is going to become 1 minus x e raised to minus 2x divided by 2. This is minus and minus becomes plus 1/2, and then we're going to have here integral of this thing, integral of e raised to minus 2x dx. Okay, so we have to find integration of this, but if we come back, we know we have found the integration of this, which was v. We found integration of this, and v gave us minus 1. V was minus 1/2 e raised to minus 2x. So this expression here is the same as v, so you don't have to solve it again, just have to replace by v. So this becomes minus x e raised to minus 2x divided by 2 plus 1/2, and then minus 1/2 e raised to minus 2x, which was the value of v there, okay, minus 2x. And now we can put our c in the end of all of it. Now we have just organized this. It's going to become minus x e raised to minus 2x divided by 2, and then this becomes minus because we have plus and minus, and then this will become 1 divided by 4 e raised to minus 2x plus c, and it is done. And with this we conclude the study of the integration and methods of integration. In the upcoming videos, we're going to study the applications of integration. We're going to find improper integrals, we're going to find integrations that are going to find volumes, double integrations, triple integration, and so on and so forth.